Okay, hello, assalamualaikum. So this is the continuation untuk last class lesson, which is electrolytic cell. Okay, so we stop at one of the factors affecting. Okay, so I repeat lah. Okay, there are 3 factors affecting the selection of ions. Okay, to be discharged. Alright, so now first one kita dah discuss lah, kita tengok E naught value, and second one is concentration, and this one I dah cover on. Okay, concentration kenalah ada concentration of solution. Okay, of course we have one is concentrated and the other one is diluted. Okay, so last class dah bagi example on concentration, and today I'm planning to give example untuk diluted. Okay, before that, diluted is biasalah. Diluted, let's say we have okay, example. Alright, now let's say if I have macam number 4. Okay. Electrolysis of potassium chloride solution. Okay, so first step, okay, good, step by step lah. So kalau nak senang visual, we need to draw dahulu beaker. We have our electrode. Okay, this one usually I can given lah. Alright, now when they mention KCl solution, just potassium chloride solution, ada tak dia mention concentrated or diluted? So if not, you just assume this is diluted. Kalau tak mention, assume diluted. Alright, so macam biasa, step by step dia cakap solution. So inside got the ions, we get K plus Cl minus OH minus. Okay, I like to put my cation kat one side and an ion together. Okay, so now kita dah settle first step, and then you must label. Okay, the longer side is a positive and shorter side is negative. So you put here attracted to the positive side. Remember, opposite attracts. Okay, now you just rujuk your table page 24. Tahu kan, the SEP table ada E naught value and stuff kan. Value, you tengok. Okay, so you ambil sahaja from so we on to our second step lah, the selection of ion. Okay, so you know that the K plus and H plus is going to cathode, correct? So cathode, between potassium and hydrogen ion, we need to choose the one more positive. Okay, more positive. So you need to choose, cakap cathode lah, we just divide lah into 2 parts. Okay, cathode and anode. Alright, so at cathode, which is cathode is the negative terminal and anode is positive terminal. So at cathode, K plus and H plus is attracted, and you'll find that kalau you tengok, you'd have hydrogen would have more positive E naught value. Okay, please rujuk balik, refer back to page 24 lah. Page 24 ni ada list of E naught value. Okay, kalau you tengok, H plus would be selected. Okay, selected, so would be selected because what? H plus has more positive E naught value than K plus. Alright, next let's look at anode. Okay, terbalik pula. Now this is a positive terminal, so dia akan choose yang the one more negative. Okay, kalau you tengok between Cl minus and OH minus, you akan jumpa yang OH minus akan produce more, yang produce more inert value, more negative inert value. Okay, so OH is chosen lah, because would be selected because OH has more negative inert value than who? Then Cl. Alright, gitu. Okay, and macam biasa, after that you need to letaklah your half equation. Okay, so that step would be to write your half equation. Something else. Okay, so macam biasa we divide lah into anode and cathode. Alright, so this one you silent saja balik. Okay, and make sure untuk adjust mana-mana yang akan receive and donate. Okay, make sure that you know electrolysis from positive to negative. This is the electron movement. So at positive terminal anode, OH yang akan menderma. Menderma meaning, donate meaning dia punya electron is at the right side. Okay, please check. Alright, so at anode, which is the positive terminal, you cari saja at, please refer back. Refer page 24. Okay, page 24 also. So you'll see, just copy back. Kan, like we discussed from last class kan. Okay, nothing new lah, nothing new. And at cathode, macam biasa, dia akan receive. Okay, kalau one party donate, one party will receive. Okay, alright, and our fourth step, which is the hardest yet lah kan. Fourth step yang selalu orang kecundang lah. Kecundang because what? Tak memorize dia punya colour and stuff. Okay, so macam I repeat, macam I cakap last class. Okay, I repeat back. Kalau if it produce non-metal, kalau dia punya product is non-metal, you'll see a gas. Okay, kalau produce a metal, you will see a solid. Okay, alright, so now let's look at our after lah. After meaning after the arrow. Okay, after the arrow is this part lah. Okay, the product. Alright, now macam biasa, anode and cathode. Alright, now okay, you see between O2, 2H2O and 4E ni kita nak ambil yang mana? Obviously we're going to take O2 lah. H2O is just water kan. That's not really observation, betul tak? So we're going to tengok balik our oxygen. Oxygen gas warna apa? So if you write colourless gas, then wrong. Kalau colourless gas kita tak nampak, and observation should be observable. Okay, kita patut boleh nampak dia punya observation. Okay, what change? So you must mention bubbles. Okay, colourless gas bubbles. Okay, how about cathode? Hydrogen also no colour, so colourless gas bubbles also. Colourless gas bubbles is formed or produced. Alright, that's it. Okay, and so this is example untuk diluted lah. Okay, how about what if it's concentrated kan? Last class also I give already kan example. So this is another example, just to make sure that you okay lah. So let's say we have electrolysis of 1.0 mole per dm cube of, let's take copper to chloride. Okay, put solution ni lah. Solution. Alright, so now macam biasa, you need to visualize. Lukis saja, anak senang-senang aja. Okay, and then we have our battery. Okay, and inside here, kalau you tengok, they mention about 1 mole per dm cube. This is concentrated. Okay, concentrated. Okay, so bila, macam mana nak tahu the bacaan of the concentration? Is it concentrated or cair? Okay, so kalau dia alright, ni take note okay, diluted dengan concentrated. Okay, kalau diluted, the concentration is less than 0.1 mole dm cube. Kalau concentrated, it's more and equals to 0.1 mole per dm cube. Okay, clear? So this one is categorized under concentrated. Okay, so it's concentrated lah. Alright, so now inside ada Cu2 plus, Cl minus, ions are ions inside, H plus and also OH minus. Okay, now step 1 settle. Okay, step 2 ialah untuk macam biasalah. Lagi kalau dah biasa tak payah nak ingat apa sebenarnya, like instinctual je sebenarnya. Alright, so kita tengok dia punya movement of ion. So the positive would go to negative terminal, or also known as cathode. Okay, this one will go to positive. Right, so now kita tengok mana yang akan dipilih. Okay, alright, selection, divide into 2 parts, anode and cathode. Okay, now dekat, okay, alright, dekat anode, which is the positive terminal, kita akan tengok Cl, between Cl minus dengan OH minus. Okay, remember, kalau dekat anode, kita akan pilih, usually it's more negative kan, tapi kalau you tengok OH lagi negatif, tapi nak pilih Cl. Okay, please take note that this is concentrated, so you kena choose the halide ion. See, halide ion akan dipilih. Why? Because the solution is concentrated. You cakap macam tu. Okay, so Cl would be chosen. Okay, so Cl akan dipilih untuk discharge. Okay, so itulah lah tadi, Cl is chosen. Kan, kenapa to be discharged? Why? Discharge. Alright, why? Because the solution has more Cl minus ion, or you can say apa, the concentration of ni better lah kot, the concentration of Cl minus ion is higher, lagi banyak. Okay, alright, next, cathode. At cathode, macam biasa, you're going to look for the one yang lagi negatif. Okay, lagi positif. Okay, sebab sekarang, cathode ni kan negatif terminal, so between Cu2 plus dengan H plus, dia akan pilih yang kan opposite attract, dia pilih lagi negatif kan. So mana lagi pilih lagi tu, mana yang lagi positif, opposite attract. So kalau dia negatif terminal, dia akan attract yang positively charged ion. Okay, now kalau you tengok, Cu2 plus akan discharge. Okay, please refer to page 24. Right, so you write lah dia punya reasoning. Cu2 plus is chosen, and use the same reasoning tadi. Okay, why? Okay, I'm sure by now dah okay got half equation. Second, third is half equation. Alright, now also divide into 2 parts, anode and cathode. Okay, at anode, siapa tadi? Anode Cl. Cl ni tadi kalau kita faham the movement of ion for electrolytic cell is positive to negative terminal, meaning from anode to cathode, correct? So anode tu, meaning dekat anode ni, whatever at anode is, dia akan donate meaning electron on right hand side. Okay, dia dah let go the electron. Okay, so you copy back from page 24 atau from stretch also can, sangat senang. Cl akan jadi Cl2, so you're going to add 2 here and add 2 here for balancing. Okay, so of course kat cathode dia akan receive. Okay, so Cu2 plus becoming Cu, and then your electron here. Okay, faham Alright, last part. Okay, let's try do together lah untuk observation ni. Sangat senang. Okay, anode and cathode. Okay, now remember, if it produce a non-metal, you see a gas. If it produce metal, you see a solid. Together, kita akan bulatkan ini dan ini. Okay, tengok anode dulu. Anode is chlorine. It's chlorine gas. Okay, that's chlorine gas. So please hafal, chlorine gas is what color? Is greenish yellow. Okay, greenish yellow gas is formed. Okay, settle. And for cathode, if you see, it's Cu. This is metal, what kan? Metal, so it's solid. Okay, and then you remember back, copper solid what color? It's brown, right? So all metal except copper is grey solid, except copper. Copper is what? Brown. Okay, so brown solid is deposited. Okay, deposited. Okay, or lagi satu ni I tunjuk something. You can see, you can cakap pasal dia punya solution dalam ni. Okay, remember, inside the beaker got, tadi kita ada Cu2 plus ion. Islah, these 4 ions kan. Okay, okay, I nak tahu Cu2 plus ni warna apa? It's blue kan. So you bayangkan dalam ni ada Cu2 plus, banyak kan. Cu2 plus, okay, banyak. Okay, you bayangkan tadi what happened. Kalau kita tengok from half equation tadi, at cathode, our Cu2 plus ion ni, dia receive electron to become copper solid. Okay, so dia discharge kan. Discharge mean dia buang charge. Okay, so you bayangkan dari berapa ni, 1, 2, 3, 4, 5 for 5 ions. 5 ions ni dia, okay, you bayangkan like 3 of them dah jadi copper, become copper. So inside beaker left with 2 saja. You bayangkan tadi is very dark blue because ada berapa ni? Tadi ada 5 copper ions. Now ada 2 saja left. So you bayangkan blue tu dark ke jadi paler sikit. Of course it's going to be less dark kan, paler kan. Sebab apa? Copper ion not so much anymore. Tak banyak macam before. So you can say what? Blue color of solution becomes lighter. Okay, ataupun paler. Ataupun jugalah, kita tak kisah. Why? Because the concentration of what? Of copper ion in the solution decreases. Settle, right? Kan? Okay. So, already covered on one. Okay. On to our third factor. Okay, third factor would be, okay, now this one tadi kita dah buat tadi is what we call as inactive electrode, inert lah, inert electrode. Okay, inactive. So now kita akan buat pasal type of electrode, and this time we use active electrode. Okay, active electrode. So we got two, inert, inactive lah, and active. Okay, so now we're going to look into our third factor, affecting the selection of ion to be discharged. Okay, so the first one tadi, the first one and the second one dah settle, settle. And the third one is when we use tengok active tak electrode tu. Okay, so how do we know? Okay, so electrode ni ada electrode ada dua lah, inert and active. So before this we've been using inert punya, okay, because kalau you tengok kan, we always use apa dia, carbon, right? Carbon. So that is inert electrode. Okay, now kalau active ni macam mana? Active meaning other than carbon lah, other than carbon. Okay, other than carbon. Alright, let's see one example lah. Okay, sekejap, saya cari yang senang-senang sikit. Okay, this one first. Alright, so we have contohnya we have examples electrolysis of copper lah, then copper to sulfate solution using active electrode. Alright, now what does it mean by active electrode? Kita tahu dah, other than carbon, but kita nak guna apa, kan? Kita perlu lukis dulu. Okay, now inside here is aqueous, copper to sulfate lah. Okay, solution kan. Alright, and then cerita dia, kalau dalam kita punya electrolyte contain the metal ion, which is for this case is copper kan, then we're going to use copper. Gitu. Okay, so remember we must use the same metal, the same kind of metal lah, type of metal yang kita guna inside our electrolyte. Dia kena macam tu. Alright, now then the next step is sama saja macam tadi, which is we have to list down the ions yang ada dalam the electrolytes, H plus and OH minus. Okay, and then determine the movement. We have our cation attracted to the negative terminal, while an ion attracted to positive terminal. Okay, alright, so kita boleh terus sembang pasal ions to be discharged. Okay, okay, for this please focus because this is a bit different from usual. Okay, so now kalau kita pakai active electrode, if use active electrode, then apa yang akan di discharge? Okay, metal yang kita guna, metal that is used is going to be discharged. Macam pelik je my English. Ion to be discharged is the metal lah. Is the metal. Alright, apa maksud ni? Okay, So sekarang macam biasa, kita akan divide into two parts, our anode and our cathode. Okay, so apa yang kita berpegang dengan is copper lah for this case kan, because metal, when it comes to active electrode, metal yang akan discharge. Macam mana tu maksudnya? Okay, so okay, dia punya konsep sama. Electrolysis, electron moves from positive terminal to negative terminal, correct? So anode is positive, cathode is negative. So anode is going to donate electron. Donate electron meaning electron sits at the right side, okay, right hand side. Alright, now you just think, kalau copper and both are like kita involve copper and copper 2 plus lah kan, so copper only, this is between copper only, because this is active electrode. Okay, now at anode, at anode now is kalau kita dah tak apply dah this one. Okay, alright, copper, oh nanti saya cakap ni apa. Alright, so sekejap, tak apalah, cakap dah sekarang supaya tak forgot. Okay, so kan tadi kan kita tak guna kan the one here, tak guna langsung. Why? This is what we call as spectator ion. Okay, they just spectate. Okay, so they call it spectator ion. Alright, it's just going to be there for the sake of, I don't know, just be there. Okay, so they call it spectator ions, just spectate. Alright, now sambung to our discussion. Okay, so how do we make our electron on the right hand side? So of course this is the only possible ways kan, akan ada dua saja, sama ada ini or is either Cu2 plus plus 2e or Cu2 plus 2e and Cu. So kita punya principle tadi is electron move from positive to negative terminal. Okay, positive terminal ini dia akan donate, while negative terminal dia akan receive. Okay, so logically yang atas lah yang akan would be the half equation for anode. Logic kan? Okay, so now bawah you just salin balik that one, 2e and Cu. Okay, settle. So kalau you nampak sekarang kita ada this half equation, we can conclude bahawa at anode the metal become ion, while at cathode the ion become metal. Okay, let's see the observation sangat-sangat, bukan sangat-sangat lah, usually people got wrong lah for this one because it's a bit different, but sangat biasa saja for me. Okay, you have to senang saja, once you understand actually it's not that bad rasanya. Okay, now observation and not cathode. Alright, so at anode tadi I said metal to metal ion, correct? So what happened here is sama macam before ni, kita nampak dia akan so let's see here lah kan, this one dia akan corrode because the metal become metal ion, obviously dia akan corrode. Okay, okay, so dia corrode into where? Into this solution, so dia jadi Cu2 plus gitu. Okay, dikeluarkan. Alright, so we can say copper anode dissolve, or you can say corrodes, tak kisahlah. Okay, what about the cathode? Okay, cathode tadi from ion to metal. What does it mean? Ion to metal. So, jadi inside the solution got Cu2 plus also kan? Kan? So, the Cu2 plus akan di-discharge here. So, what happen? Akan ada, what's the colour of copper solid? What's the colour of copper solid? It's brown. Okay, it's brown. So, you can see brown solid is formed. Brown solid is formed. Okay. Okay, ada lagi satu observation. Okay, this one dia suka sangat tanya. Alright. Okay, can I ask, what's the change of the color of the solution? Ada change tak? What's the change in the color of the solution? What's the change? Time's up. Okay, now kalau kita fahamkan tadi, at anode dia leaches out copper ion kan, betul tak? Let's say here dia keluarkan dua copper ion. Tak lagi nampak dah kan, dekat situ dua kan. Here dia keluarkan dua copper ion. Okay, contoh. While in the beaker copper ion ada dua, bayangkan. Okay, but the dua copper ion is being discharged here. So what happened here? What happened to the solution? You bayangkan dalam output is, tak adalah output, input kan, pening pula. Dia keluarkan dua, so ada dua copper ion yang out kan. While out meaning dia dah keluar lah, dia keluar daripada beaker tau. Keluar daripada beaker tak apa, maksudnya dia dah di discharge tadi kan. Dia discharge tadi, tu copper ion out. While ada berapa lagi yang masuk? Yang masuk berapa? Here, yang masuk to the beaker is dua juga. In also two copper ion. So sebenarnya the solution stays the same, remains unchanged sebenarnya. Sebab two out, two in. Two out, two in. But how do we say that? Takkan nak cakap because two out, two in. Takkan nak cakap macam tu kan? Okay. Ni. Alright. Please take note. Okay. So you can say blue color. Okay. Remember the color of copper ion is blue. Okay. Please hafal. So by now macam dah hafal lah kot kan. Kalau tak hafal lagi kan. Okay. Blue color of solution remains unchanged. Why? Because the rate of use this ayat the rate of copper 2 plus produced at anode is the same as the rate of copper 2 plus discharge at cathode tadi. Cathode. Hence concentration of copper ion in the solution tak change. Alright. Hence terlibat pula, tak buat pula. Sama sini lah. Okay. Hence concentration of Cu2 plus ion in the solution does not change. Okay. Boleh. Two in, two out. That's basically it lah. Okay. I repeat lah. Dia tak nampak pula kecil kan. Okay, the blue color of solution remains unchanged because the rate of copper 2 ion produced at anode is the same as the rate of copper 2 ion discharged at cathode. Hence, concentration of copper ion in the solution does not change. Boleh? Okay, so with that knowledge in mind, active electrode lah kan, tadi kan dah faham kan. It involves copper ion, ingat tak? Copper ion and copper metal. Okay, so sekarang kalau dia pakai active electrode, kita are going the ions that is going to be discharged is only the metal ion. Boleh? Okay, so now ingat tu. Remember in your head, please register to your brain, jangan lupa. So this one application, this one is it's all about using active electrode. Okay, so let's go. We go to the application. Okay. application of electrolysis. Okay, so first one is electroplating. Second is purification of impure metal. Okay, SPM focus is we're going to use copper. And then last one is extraction of aluminium. Okay, let's see electroplating first. Okay, now let's talk about the purpose dulu. Okay, remember yang ni pernah belajar dulu masa form 3, okay? Because science form 3, okay? Electroplating is basically the action of transferring. Okay, let's say we're going to coat lah, senang nak cerita. It's going to coat. Okay, let's say you have a ring. This is a shiny ring but not so shiny anymore. So you nak improve lah the appearance kan, you nak cantikkan dia. So you're going to use electrolysis. You connect lah dengan apa yang you suka kan. Let's say you want your ring to be plated kan, to be plated with silver. So you letaklah silver. Macam tu. Itu saja. So nanti lambat laun lah. After that your ring akan be covered with, plated lah, we use the plated lah, plated with silver. Cantik lah, improve the appearance. Okay, so the first point is what? To what? To improve appearance. Improve appearance. Okay, and then what happened tadi to your ring ke, to your keys ke, kunci pun boleh. Okay, because it can prevent rusting also. Prevent rusting, or we call as corrosion. Okay, corrosion. Okay, now the type of electrode that we're going to use. This is okay. So we're going to use electrode. The electrode. Dekat anode and cathode is different lah. So anode is always going to be the metal lah, meaning it's either silver or gold. Okay, and at cathode, the one that is going to be plated. It's highlight here lah as your note kan, to be plated. So whatever you want, it can be either ring, can be key, and then can be iron spoon. Boleh. Now our electrolyte pula. Electrolyte. Always misspell my electrolyte. Okay, electrolyte, you follow dia punya material. Let's say you want to use silver dekat anode. So the electrolyte must contain silver. So I suggest like hentam-hentam je lah. Silver apa? Silver nitrate ke, silver sulfate ke, tak kisah. Boleh. Silver nitrate lah contohnya. Tak kisah. Okay. Terbaik betul note lah kat here. When using active electrode kan, dia punya anode must contain cakaplah, must contain the same material as the anode. Gitu. Okay, ikutlah. Okay, next our half equation. Tiba-tiba ada half equation. Let's draw. Let's say you want to plate your ring lah tadi kan. Take note drawing ni penting. Selalu suruh you draw. Okay. Focus this one. Okay, now Okay, take note. Nampak tak I lukis ring ni must be fully submerged, okay? Must be fully submerged dalam the electrolyte. Because what? Kita bukan nak cover separuh saja, okay? So kalau let's say you lukis macam ni, let's say kan, dia terapung kat sini lah, somewhere here kan. Sekarang ni salah, okay? Dekat dalam skema dia akan tulis the ring must be fully immersed, okay? So kalau you lukis kena betul-betul bawah tu. Boleh. So kita nak cover, nak platekan semua ring, bukannya only the lower part. Remember? Okay. Alright, now this one for the placement of electrode. Kita tak payahlah nak fikir-fikir gila nak hafal kan. Electrode letak dekat anode. The one that is going to be plated letak kat cathode. Janganlah fikir macam tu. Bukan, I mean like can fikir macam tu. Tapi tak payahlah hafal. Janganlah sampai to the extent yang hafal kan. Okay. Kita tahu elektron bergerak from positive to negative, betul? So janganlah nanti buang kepala otak kau orang nak kena hafal kan. Tak nak hafal boleh, kalau kuat ingatan is okay. Alright, so kalau kita faham from here positive to negative, meaning dekat positive ni yang akan apa? Akan mengurus lah, akan thinning, while the one that is at cathode is going to be gemuk kan. So kita nak gemukkan yang mana, yang want to kuruskan which one? We want to gemukkan this one lah, the ring kan. Kita nak coverkan dia, nak platekan dia. Okay, so of course going to be at negative electrode, boleh, negative terminal. Okay. So with that in mind, let's say we use I bagi soalan terus lah. Let's say we use Ag nitrate tadi, silver nitrate solution. Okay, so now this one is active electrode. So the half equation, the one that is going to be discharged and all, is always the material, the metal. Okay, half equation at anode and cathode. Okay, now kita faham anode is the one that is going to donate. So our Ag becomes Ag plus E, while at cathode is going to receive. So terbalik ajar. Boleh ya? Sangat senang. Okay, so that is your simple illustration lah. So you kena label also lah, macam ni itulah. This one apa? Ag gitu. Okay, make sure tally macam mana your electrode dengan your electrolyte of the same material. Okay, so what happen is, kalau you tengok, dia akan mengurus macam mana? This electrode, silver electrode tu, dia akan corrode jadi kurus lah, macam tu. Gitu. What happen? Dia keluarkan Ag plus ion. So Ag plus ion in the solution akan coat the ring. So dapatlah cantik. So tulis sini dia corrode. So that's the observation. Boleh cakap dekat anode kan, anode tu dia punya silver electrode would corrode. Okay, while the ring is going to be plated lah. Okay, settle kan, senang kan? Alright, let's go to purification. Okay, sangat senang soal. Okay, purification also easy, the same concept. Okay, the same concept. Okay, so the purpose is to, nama pun purification of metal, so to purify impure copper to obtain pure copper. Okay, now apa yang kita faham tadi from our ring tadi tu? Okay, sekejap dulu lah.
Okay, now yang akan okay, sekejap. Dia movement dulu. Kalau kita faham yang akan gemuk is this one, gemuk. And this one akan mengurus thinning. Okay, so apa yang kita faham from here, dia nak purify the impure copper. So what do you think? We please, pure copper dekat mana, impure copper kat mana? So my cadangan is kita misalnya okay, wait, let's just use a stroke user. Alright, now kita buat warna lain-lain lah kan. Okay, now my suggestion is we're going to put our impure copper here. Impure copper here. Okay, because what? Impure copper ni maksudnya dia ialah copper, but then dia ada impurities. Okay, impurities tu macam kotor-kotor lah kat sini. Kan, kotor-kotor kat sini. Boleh. So kotor-kotor kat sini kita nak bersihkan dia lah. We're going to obtain pure copper from the impure copper. So obviously we're going to kuruskan the impure copper. So what happen? The impurities akan keluar, and then nanti dia akan pergi kat sini pula. Macam tu. Ini pula yang akan gemuk lagi. Okay, this one akan jadi gemuk, while the anode akan jadi kurus. Okay, so faham with that understanding in mind, let's just tengok dia punya pump dia. Okay, so our electrode at anode must be impure copper, while at cathode is our pure copper. Okay, again, electrolyte, what do you think? Sama lah. Sama material. So copper kan, kita pegang copper kan, hantam je. Copper apa? Copper tu sulfate ke, nitrate ke, chloride ke, tak kisah. So macam saya cakap tadi, any solution that has copper, gitu. Okay, so what happen tadi is, macam saya cakap tadi, mana satu yang akan keluarkan. Okay, so anode akan leaches out electron. So let's do our half equation here. Copper 2 plus, copper 2 plus. Kita try je. Copper become copper 2 plus. So that electron tu sits at the right hand side. You try saja. And then cathode Cu2 plus 2e copper. Senangnya. Dah, settle. Itu saja. So, kita nampak kalau observation dia tadi from, kita tak payah buat before after lah. Senang. Okay, this is before. This is impure Cu. This is pure Cu. Okay. And then this is your solution, copper sulfate contoh. Okay. Now this is our before punya figure. Okay. And let's see our after. Okay. Our after. Okay. Our after dia jadi okay. Now the one at anode akan korot. Okay. Korot. Okay. And the one at cathode akan ada metal. Metal what? Metal what? Copper lah. Copper deposited. Deposited. Okay. That's it.